Welcome to this tutorial on CTC's MEP Productivity Pack for Revit. In this video, we will review the Universal Fixture Contents Track Lighting. The Electrical Productivity Pack features a workflow for modeling and circuiting track lighting, which calculates load based on the length of the track as required by the National Electrical Code. In the sample project, lighting track and track heads are separate families. Both are lighting fixtures placed with the lighting fixture command. The pack features both single circuit and dual circuit track. Let's look at single circuit track first. Placing an instance of the track on the ceiling, we see that its default length is 2 feet. We can change the length directly in the Properties palette, or we can change its length by dragging its grip at the end. We can also align the end with the grip and the track will stretch. Aligning the other end will move the track rather than stretching it. The National Electrical Code, paragraph 220.43, requires that track lighting load be calculated according to the total length of the track. So, we can see here in the Properties palette that this family has load, even though no track heads are placed. As we change the length of the track, the load changes. The parameters that control the load of the track are type parameters. They're located in the Electrical Loads group, VA per unit length, and unit length. The NEC requires that track lighting load be calculated as 150 VA per every 2 feet of track or fraction thereof. You can change these values if you need to meet different requirements, but they are set to NEC values by default. So if we close out of here and change this length back to 2 feet, we see the family's load is 150 VA. Any length between 2 feet and 4 feet will calculate as 300 VA, and anything between 4 feet and 6 feet will calculate as 450 VA. Any fraction of the entered unit length will round up to the next multiple of unit length. If we circuit this to a panel, we see that the load reports on the panel appropriately. The NEC provides an exception to paragraph 220.43 that allows a current limiter to determine the load of the track rather than its length, and this family accommodates that exception. If we take a look back over here in the Properties palette, the fixture is 5 feet long, which has a calculated value of 450 VA and a current of 3.75 amps. Up here, we see a checkbox parameter, Current Limiter Override, and an amps parameter, Current Limiter. Checking the box overrides the calculated load with the value from the current limiter. The value for the current limiter is 0 amps, and now we see that the fixture's load is 0 amps and 0 VA. We can change this value to 1 amp, and the fixture's load changes accordingly. Now that we've reviewed single circuit track, let's look at dual circuit track by changing this type. The dual circuit track works identically to the single circuit track in how it stretches, but we can see here that there are 2 electrical connectors and 2 sets of load values over in the Properties palette for Circuit 1 and Circuit 2. Within Type Properties, power factor and VA per unit length are separated into Circuit 1 and Circuit 2. The default value is set for 75 VA, or half the NEC requirement. There's only one unit length parameter that applies to both circuits, and one voltage, phase, and number of poles parameter. Changing the fixture's length changes the values for each circuit separately, and the current limiter override is still here as well, one for each circuit. When we power the fixture, a dialog box will appear asking if we want to connect Circuit 1 or Circuit 2. Let's select Circuit 1, name it Circuit 1, and we can see it appear here in the panel schedule. If we go back and power again, it will circuit the only remaining electrical connector in the family, which is Circuit 2, and we'll also see it appear in the panel schedule. Let's take a look now at track heads. The family intended to be used in conjunction with lighting track is this one, Track Light, No Load. There is another family up here with a pre-configured track light type called Directional Cone. These 2 families are identical, except the track light family does not have an electrical load associated with it that connects to the electrical system. When calculating track lighting load per the NEC, the directional cone should not be used. It's for other directional lighting applications, such as a single track head on a spot mount. Let's select the track light family and select Place on Face. Notice immediately the warning. This is a warning to users that this family does not place load on the electrical system. This warning is here in order to prevent user errors. We can turn it off by unchecking the instance parameter, Show Warning. Let's host a few instances of the light to the track. If we take a look at these in 3D, we'll see that the trackhead family features a universal light source. See the user manual and tutorial videos on how the universal light source works. This family also has an angle adjustment so that each fixture may be aimed for accurate photometric calculations. In the family's type property, we still have load information. Here's current, apparent load in watts, and down here is voltage and phase. These parameters, particularly the watts and voltage parameters, are here for the lighting fixture schedule only. They are not connected to the family's electrical connector, and they will not be seen by the modeled electrical system. So even though we see here that each fixture is 38 VA, if we close out of here and circuit all of these lights together on a new circuit, that circuit will have no load. Let's delete that circuit and see how we can connect these to the track circuit. If we select the track and go to Electrical Circuits, normally we would simply click Edit Circuit to add fixtures to the circuit. But this track has two circuits associated with it, so we have to be sure we're working with the correct one. We do that with the System Selector. This is a drop-down menu which lists all circuits associated with the track. The only information it provides is panel circuit number, so we have to know which is which. We connected track circuit 1 to circuit 1 in the panel, and track circuit 2 to circuit 3 in the panel. Let's say we want to circuit these two fixtures to track circuit 1, and these two fixtures to track circuit 2. We're working in panel circuit 1, which is track circuit 1, so edit circuit, add these fixtures, and finish. Change to the other circuit, and repeat for the other two fixtures. Of course, you can also circuit these together from the start. Let's delete both of these circuits, and then select the track and the first two fixtures and power. Revit will still ask whether we want track circuit 1 or track circuit 2. Select circuit 1 and repeat for circuit 2. Before we go, let's quickly take a look at how track lighting is used in the sample project. Here is the conference room on the first floor of the sample project. At the top of the room, we see single track heads. This is the directional cone family, which contains load. Over here on the left, we see an example of single circuit track. The track and the track heads are on the same circuit, and the track is tagged with circuit number and controlling switch. On the right, we see dual circuit track. The track is tagged with its type, but not with circuit number since there are two circuits. Instead, each individual track head is tagged with circuit numbers and their controlling switches. Now you know how to use the track lighting content within CTC's MEP Productivity Pack. Thanks for watching, and be sure to check out our other tutorial videos linked in the user manual.